Okay, so today we're gonna just go through assignment, the assignment concerning the Davis Southern Club. Um, so this is a classic bipartite network with two different types of nodes. In our case, we have a set of nodes representing women and a separate set of nodes representing clubs or events. And so the way the network works is that uh, a woman can attend an event, and the objective is to be able to take this bipartite graph and then project it onto the nodes of the same type, so that way we can see connections between women's and connections between clubs. So we start by uploading the data to our notebook. It's part of the library Network X, and this is us just importing it here into G, and then we print the by adjacency matrix to kind of see what we're working with, and just a quick explanation of what the matrix represents. So this first set here represents women and events, with women being index 0 and then events being index 1. So this women at index 0 and event 0 was attended. So there is a connection there, meaning that there would be an edge between this woman on our bipartite graph. Any events that aren't attended, which is not show up in the matrix, right? That's how we capture that information. Okay, so now that we have the bipartite graph, our next step would be to project them into the different types of nodes, and that's what we're doing here with W and E. And we could just run this, and then here, what we see is that we projected that data onto the set of women nodes, and then we were able to find connections between women who attended the same event. So Evelyn, there are 18 women in the data set. So Evelyn, Ruth, Halen, Nora, Sylvia, Vernay, and Teresa, they have all interacted with everyone else in the women network. Um, so they would be the most closely connected among all the women here, right? They've all attended events where every other woman has been at. Okay, and then we do the same for clubs, and uh, the way that we so it's the same thing uh, in 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 our projected uh, in our projected graph for the clubs or the events. The clubs are connected if they share at least one common member, right? And so we see that event 6, 7, 8, and 9 are connected to all other events, since there are 14 total events in the data set. Okay. So then our next step is to kind of get like a weighted representation, especially for our women nodes, just to see like the total number of connections. Um, so like so basically for a specific woman, how many different connections does she make with other women in total? It doesn't matter, and they don't have to be unique. And so we run that, and here we see that Teresa has the total. It has the total meetings of 57, meaning that she's had 57 different interactions with all the other women in the club across all the events that she attended. And then we see that Flora and Olivia are kind of like the odd women out, meaning that they've had the opportunity to interact with the fewest members in total. Okay, so this next plot is just the plot is the graph. It's an unlabeled graph that was given as an example for the data set. Um, we can't really gain any information here. Nothing is labeled. We just see some nodes that are kind of like in the middle and are connected to everything. But it's hard to see. It's impossible to find out what is what here. So in the next plot, I take this and I just label it make it a little bit easier to understand. So yeah, so now we're able to see the different women and then the events. And then again, so it's kind of hard to see here, but events aren't connected to each other. It's women that connect to events. And this is the original bipartite network. So then what I did was I wanted to find out how important events are by the amount of women that attended each event. And that's what this cell does here. And then it orders it in descending order. So we see that event 8 had the most attendees, followed by 9 and 7. And then we see that that events 10 through events 1, 2, 13, and 14 all shared the least amount of attendees. Okay. And then I also wanted to know how many events did each member attend. And for that, we just did um, uh, a simple account here of connections for each woman to each event. And we see that Evelyn, Teresa, and Nora attended the most events. And then Flora, Olivia, and Dorothy all attended just 2 events. And then finally here I have some interactive code that allows us to like pick the event and see a visual representation of the women that attended that event. So we're gonna do the most important event here, which was 8. So remember we're dealing with indexes. So 8 minus 1 will be 7. So we're looking at index 7. And now let's see what we get here. So yeah, here we go, event 8, which is what we wanted. And then we got a print of all the women who attended that event. And if I remember correctly, I think there were 14 women who attended this. And then we see all the ones that were attended in blue, right? And then we could easily change that by running it again. And this time, I think event 10 had only 2 women that attended, or 3. Let's see. Okay, so event 11 had 4 women who attended, and we see that it's one of the events on the outer edge of the network because it was one of the least. I think if we look at events 13 and 14, these only have. So let's run that one more time. That's 13, 12 this time. Okay, perfect. So yeah, so here we see that indeed event 13 only had 3 attendees. And again, we see how Network X takes this information to populate the plot, and we can also see the connections of the women nodes to that event. And then this final cell just calculates some different centrality metrics. So we're gonna run that, and then we see that we have some within the women network. We see some full degrees of centrality, and that makes sense since we have various women who had connected with all other women throughout the network. Yeah, so we kind of see a lot of the same metrics for these women, and it just highlights what we saw earlier, that these women, we come up here, right? We had 7 women who had interacted with all other women, right? But then if we see like Charlotte McDowd and Flora Price, we definitely expect to see a lower degree of centrality there. And indeed we do, as these women have interacted with far fewer of the other members in the network. Yeah. So that takes us through what we explored with this data set. And then um, I think my final thoughts are explained in this markdown cell. So the uniformity in the top degree and closeness score suggests a dense, well-integrated social structure among core members, which is true. Furthermore, in contrast, the lower Ivan Dector and between scores among the peripherals members, so Olivia, Flora, and Charlotte, and Flora Price indicate limited structure influence. They are loosely tied to the network's core, contributing little information to the flow and to group cohesion. And I did have something that I wanted to talk about. Yeah, events. So I remember we first looked at event 8. Its attendees are shown in light blue. So we can see that women who did not attend event 8 also tend to have the fewest connections to other members, and that was just from our observation and comparing that to the above cells for the total weight of each woman node. And so this suggests that not only the number of events attended matters, but which event also matters, right? Like, so if you know that there was a big event where everyone was going to be at, you probably want to prioritize those types of events in the future, so that way you expose yourself to other members of the group, and therefore, if your aim is to cement yourself as a node of information or central node within the network, that's how you would leverage that. Okay, so that brings me to the end of the presentation. Thank you for your time.